Okay, so let's take a look at an example of putting together two functions using this idea of combinations or our algebra of addition, subtraction, multiplication, and division. So in this first example, we're given two functions. F of x is equal to x minus 5, simple linear function, straight line. And then our g of x is x squared minus 1. So a parabola. From transformations, parabola shifted down 1. That's just for kicks and giggles. You know that, hopefully. And we're going to look at putting it together using addition, subtraction, multiplication, and division. So let's start here with the addition. So this says f of x plus g of x. We simply add them together. F of x is x minus 5. And g of x is x squared minus 1. So here is f of x, and here is g of x, and the addition sign in between the two says just put them together. So now we have x minus 5 minus 1 is minus 6 plus x squared. That's putting them together. In math, we write things in order of the powers of the exponents. So we're going to rewrite this x squared plus x minus 6, just because in math that's how we write things, descending exponents forms. Domain. Let's take a look at the domain here. Domain, f of x, x minus 5. So the domain of f of x is negative infinity to positive infinity. Straight line, nothing, no reason to kick anything out. G of x, the same deal. The domain is negative infinity to positive infinity. No need to kick anything out. Think of your graph of your parabola if that helps. We go from negative infinity to positive infinity x. Nothing needs to be excluded. So nothing needs to be excluded from x. Nothing needs to be excluded from g. So the domain of this function here we've created would be negative infinity to positive infinity. What's in both of these? Well, everything is in both of these. So the domain for this new function here is negative infinity to positive infinity. Let me identify that. Domain. Okay. Now, moving on, we have here subtraction. So this is going to be f of x minus g of x. F of x is x minus 5. Now we have our minus sign, and now our g of x is x squared plus 1. I'm putting my g of x in parentheses. Whenever we have a subtraction, in the world of algebra, I think it's really helpful to put what's being subtracted in parentheses, because remember, this negative sign here has to be distributed to everything in that g of x term, and writing the parentheses will help you to do that, kind of force you to do that. So here we have x minus 5, then distribute that negative sign, so we have negative x squared, and then negative times 1, we have negative 1. Negative, I should have said positive 1. And so again, let's clean this up. I'm going to write it in terms of decreasing exponents. So we have this negative x squared. I'm going to write that first. Then we have the positive x. And now we have negative 5 and negative 1. Did I write this incorrectly? Whoops. back here. Let's this was negative 1. G of x is x squared negative 1. So I wonder if some of you were screaming at the camera that I made a mistake there. And now, so g of x is x squared minus 1. So when we distribute that subtraction, we get positive 1. And negative 5 plus 1, here we have negative 4. So that is the function we get, our new function, f minus g. Again, let's consider the domain of this new function, and we didn't really change anything up. F of x is negative infinity to positive infinity. G of x is negative infinity to positive infinity. Here, there's no square root symbol. We didn't create any fractions, so the domain is going to be negative infinity to positive infinity. Moving on, now we're going to look at multiplication. So this is going to be f of x times g of x. F of x is x minus 5, and let me see if I can get g of x correct this time. This is x squared minus 1. So there's our two functions. Let me identify them again, just in case somebody isn't seeing it. There's our f of x, and there's our g of x. And now we are going to multiply these. So I'm going to do a FOIL multiplication. X times x squared is x cubed. So there's the first for the outer. X times negative 1 is going to give me negative x. Now the inner terms. Negative 5 times x squared is negative 5x squared. And then last, negative 5 times negative 1 is positive 5. And as usual, let's write these in order of exponents. And there is the new function that we have created by multiplying our f and g. And hopefully you can see our domain is just going to continue to be that negative infinity to positive infinity. No need to exclude anything because we didn't create any square roots or even roots, and we didn't create any fractions, so everything is still allowed to be in our domain. Last combination is a division. So this is going to be f of x divided by g of x. So f of x is x minus 5, and g of x is x squared minus 1. So we've just taken f of x and put it on top of g of x, and there is our combination, our new function that we have created. This one, determining the domain, is a little bit different. F and g were negative infinity to positive infinity. We did not have to exclude anything. So there's nothing to exclude from those functions independently. However, now in the process of doing our division, we have created a fraction here, and we have a denominator that we have to consider now for purposes of the domain. Are there values now that will have to be excluded because they would make this denominator equal to 0? So let's take our x squared minus 1 equals 0. Again, I'm going to factor x plus 1, x minus 1. This gives me x is negative 1. This gives me x is positive 1. Again, no, they can't be those because they're going to make the denominator 0. So if we do this quickly, put in 1. 1 squared is 1. 1 minus 1 is 0. So these values have to be excluded from our domain. In interval notation, the easy way to say is x is all real numbers except not negative 1 and except not 1. In interval notation, it becomes more of a mouthful to say negative infinity to negative 1, union negative 1 to 1, union 1 to infinity. And that would be the domain for this new function here that we've created.